Let's look at a few examples using scientific notation. So I'd like to convert this number into that form, and it currently is not because the value for a is less than 1. I would like to use a is equal to 2.5. So a trick here is let's take this expression. I'm going to put the number that I want there, which is 2.5, but before I write the 10 to the negative fourth, I'm going to put next to this 10 to the negative 1. What that would do is take this decimal and move it one place to the left. So you can replace 0.25 with this whole thing. And then I'm going to copy down the 10 to the negative 4. When I combine this all together, there isn't anything I can do with the 2.5, but here I have 10 to a negative 1 times 10 to the negative 4. We have a rule for this, where the negative 1 is added to the negative 4, which is negative 5. So we have a final answer of 10 to the negative 5th power. We can check to see that this is correct. I think it's going to work because over here, you have to move the decimal 4 places to the left. Here, moving the decimal 5 places to the left will take you to the same exact number. So let's try this again now, but with a 15 times 10 to the negative 4th. So we can't use 15, instead we'd have to use 1.5. So I'll use this same trick where, okay, I'm going to put in the number that I want. I'm just going to include this 10 to a power next to it. Okay, so that number would have to be 10 to the first. Because if I move the decimal one place, it would take me back to 15. And now I'll just copy down this 10 to the negative 4th. To get my final answer, I'm going to multiply these two terms together, but that essentially is, again, adding the exponents. So that is, it's now 1 plus negative 4, which is negative 3. The final answer here is 1.5 times 10 to the negative 3rd power. So now looking at a couple of examples using a positive exponent. Here we have, okay, 0.03 times 10 to the 5th. And yep, you can't use 0.03. Instead, I think we'll have to use 3. I'll place in the number that I want, but this time, let's see what happened. To get from 3 back to this number, you're moving the decimal 2 places. So that's going to be 10 to the negative 2. That is equal to 0.03. And I'll put in times 10 to the 5th. And when I simplify my work, again, I'm just adding my exponents. Negative 2 plus 5, which is 3. So I have 3 times 10 cubed. And that is definitely in scientific notation. And just one more here. I can't use 25, but I can use 2.5. So this would be, okay, I'll replace 25 with 2.5. I'll put times 10 to the first, which would move the decimal point back to 25. Then I'll put this 10 to the 5th next. If I add the exponents on the tens, I get 6. And my final answer is 2.5 times 10 to the power of 6. So like one thing to think about here is, okay, well, I decreased the number 25 and therefore I increased the exponent to 6. So I dropped the 25 down, therefore the exponent had to go up. You can use this logic on all the problems, like, okay, I had a 0.03, so I had to make it bigger by a factor of 2 tens. So this number became bigger, therefore the 5 dropped down to something smaller. This idea holds true on the first 2 examples as well, but that is all I'm looking for example 1. For example 2, let's see how using scientific notation can simplify the process of multiplying large numbers. So here we have 1.5 million, and this looks like 8 trillion being multiplied together. So it's kind of annoying to do this out on a calculator because you're going to be listing a whole bunch of zeros in a row. Instead, what I'm going to do is convert both of these numbers into scientific notation and then try multiplying from there. So let's start this by saying, okay, 1.5 times 10 to the power of 6 is equal to 1,500,000. If I use the same idea on 8 trillion, that's going to be 8 times 10 to the power of, let's see, we have 3, 6, 9, 12. So to the power of 12. Converting your values from decimal to scientific notation means you're now allowed to multiply any of these pieces together in any order that you would like. So I'm going to switch it around where instead of multiplying these two things, I'm going to multiply 1.5 and 8. I'm going to place those next to each other. And let's see, I'll multiply the powers of 10. So we switched it, and we're still doing the same thing. We've just changed the order in which we're multiplying the values. So 1.5 times 8 is equal to 12. And then 10 to the 6 times 10 to the 12th is just the same thing as adding those two exponents together to get 18. So we get this 10 to the power of 18. So we're saying we're multiplying this with this. To make it resemble scientific notation, I'll just put 12 times 10 to the 18th instead of using parentheses. But the reason for doing this is, okay, I can multiply the numbers together really easily, and if I put all the powers of 10 together, multiplying those is really simple as well. But we're not quite done. This number technically is not in scientific notation because 12 is greater than 10. I want a number between 1 and 10. So what I'm going to do is place in the number that I want. I would really like it to be 1.2, but that means I made 12 smaller by moving the decimal point once. So 12 and 1.2 times 10 to the negative 1 are the same thing. I then will just copy down this 10 to the 18th and take it one step further where, okay, the 1.2 stays, but I have a negative 1 and a positive 18 exponent, which gives me 17. This is my final answer, 1.2 times 10 to the 17th. And for the last example, same idea where I want to combine these two numbers using scientific notation, but now it's just that I'm dividing two things. So first, I'll convert these both into scientific notation. For the denominator, that would be 4 times 10 to the power of 6, because there's 6 zeros. In the numerator, the number I'm going to use is 2.08 times 10 to the power, and I got to be careful here. The decimal point moves 1, 2, 3, 4, 5, 6, 7, 8 places. And since it's going smaller, that's to the negative 8. So here we go. I've converted it into scientific notation, but just for the numerator and denominator separately. My next step will be to divide corresponding parts. That is, I'll copy down 2.08 and divide that by 4, and I'll put the powers of 10 separately in their own fraction. Now let's see, 4. How many times does that go into 2.08? So I'll just even check this on a calculator, but we get 0.52. Nice. Okay, the powers of 10, if I'm dividing, it means I'm taking the negative 8 and I'm subtracting 6, which is a total of negative 14. All I did was take this value and subtract this from it. So that gives me 10 to the power of negative 14. And I'll put this symbol for multiplication instead of the dot just to make it resemble scientific notation. And we're not quite done. So again, we're running into this problem of, well, I want it to be 5.2, not 0.52. But to fix this, I'll put in 5.2, the number that I want, and just note that I have to multiply that by 10 to the negative 1. I'd have to move the decimal point one place to the left to go back to 0.52. And if I copy down the 10 to the negative 14th, I can now add those two exponents together, give me negative 15. And this is my final answer, 5.2 times 10 to the negative 15th power.